today we will be on Scheme, okay?
All right.
So this one is considered to be the third lecture for the functional programming. So the lecture 7 is functional programming, the basic theory, right? And lecture 8 is the recursion on tree, right? That's the second talk. Third one is another language called Scheme language. It actually is Lisp language, okay?
Okay.
And we will be on this one and try to learn how to do programming with it, okay?
Okay. Let's see. What's a good IDE to program inside this language?
IDE here, this one called Dr. Rocket. So if you want to download, it's actually rocketland.org, this one. Okay. And this one is more academic. So basically, I don't think you can find some job out of this language, just purely for the understanding of the functional programming.
Okay.
So basically, I don't think this one in real world there's a job for you for doing this. But it will help your understanding of the functional programming. But basically, the most important part for functional programming is still be the recursion. Okay, recursion always the most important part. You must try to practice recursion. Okay, we have 1 more minute. Okay, now it's 1 minute to room time, so let's wait for it. Okay, hi Ryan, how are you? Hi Brendan, how are you? And I know today is actually your spring break. So if you break and travel somewhere, it's okay. And we don't require everybody here. We actually will give you a video. The purpose of this meeting time is for you to, I'm trying to help in terms of homework and whatever grading problem you may have. So that's the main purpose of the meeting, okay? And the lecture, actually, we record it in the instructional material already, so it's already pre-recorded. So it primarily is to help students to solve problems, okay? And so if you are not, you don't need help, it's okay. So we don't require students to always to be here. But on the other hand, because sometimes I'm teaching more material than the instructional material, so you join this session still be beneficial. So I may go out of bound, talking something else instead of just the material in the lecture. So as you can see so far, we get started from, our topic is programming language, right? Our topic is programming language. We already in the week 9, right? So now it's week 9 already. So our purpose is to talk about programming language. Okay. Pragmatic. So this word a little bit like a mechanism. We are talking about a mechanism. How, so basically it's actually talking about how programming language works. That's the main topic of this course. Okay. How programming language work is the main topic for this actually this coursework. So we introduce the structural programming, object-oriented programming, functional programming. And neural network we do not cover, okay? That's actually another paradigm we do not cover. Concurrent programming we do not cover, okay? Those can be a separate course. So functional programming, we are lecture 7, 8, 9, functional programming, basic recursion on tree. And then now we actually on the separate language called Lisp Scheme or Rocket. Okay, this is a language like that. Why this language is important is because it is the first. This language is the first Nanxi language. Okay, doing this processing. Okay, it's actually this processing language. Okay, and originally they come out with the idea of functional programming early in 1965, sometime like that. Already has the idea of AI and then doing this processing. So that's the starting point of the Lisp. And later, okay, this language developer and then it becomes Scheme. So modify a little bit and becomes Scheme. And then later, a few years, and it become the so-called Rocket now. Okay? So these three languages actually is one language. Actually, to me, they are just dialects. Okay? They are not really a separate language. So let's consider you are still learning Lisp, but you are using the tool in the newest one, Dr. Rocket. Okay. So you are learning a modern dialect of Lisp. That's what we are doing right now. Okay. It's this chapter's main purpose. Okay. And with that, let's actually look at first the tool, where to get a tool. Where to get a tool, you need to go to this rocket-land.org. Okay, from here you can download the newest Rocket, Dr. Rocket. Okay, the Dr. Rocket ecosystem. Okay, so you can download from here. So me, I download a version and before over here. Okay, it actually has the my editor over here. Okay, and this is the editor. So let's get started to go into this Scheme language. So here, this slides including the Scheme language, the Dr. Rocket environment, okay, and then Scheme. So when here I talk about Scheme, Rocket, and this, but sometimes I'm mixing it, okay. Myself actually sometimes got confused which is which language. They have slightly different differences, but I sometimes cannot tell what's the difference. So I need to find some information as well. Okay, but because I'm not doing Scheme every day, but sometimes I mix the language name. Okay, so don't worry, it's actually the same language, almost the same language. I would say 95% of the Lisp, Scheme, and Rocket are one language. Okay, the difference only like 5%, but you need to, if you are more detailed person, you need to know about the differences. Otherwise, we may just use the three name interchangeably. Okay. Sometimes I just say this, sometimes I say Scheme, sometimes I say Rocket. Okay. So before we go into the language, we need to talk about the history. So history, okay, actually this is created 1958 by John McCarthy at MIT, okay, Stanford Lisp Processing on IBM 704, okay. And the Scheme is developed in 1975, okay, it's a dialect of Lisp. And then Rocket is 1995, but this three language is one language, okay. And the relationship with this course would be, the relationship with this course, it would be MIT structure and the interpretation of computer programs. So the textbook we are talking about, the first version that we talk about, this one, the structure and interpretation of this one is written in Scheme, okay? So it has been used for the MIT course. A structure and the interpretation of computer program. This is a one course in MIT course. Okay, it's an MIT course, and our course is an equivalent course to this course. Okay, we teach Python, but we are a equivalent course to this one. MIT's 3.037 course, and they use the Scheme language to teach. We use Python. Okay, and you can see that the whatever syllabus they have. Okay, so this is pretty important part in terms of knowing about programming language. And nowadays, this textbook also has the JavaScript version. I make it downloadable. You can download this one. This yellow version is JavaScript version. Okay. Okay. Anyway, maybe next year or 2 years later, I'll teach our course in JavaScript. Okay. Okay, and then actually Scheme, this application is in the artificial intelligence system. So because of its functional programming nature, early day 1965, they are thinking about maybe we can build a Lisp machine, and then that can accelerate the processing of the functional programming. And then we don't need C language, and we can realize AI. So there is a research field called Lisp machine. Okay, so Lisp machine is a historical research field. People just build symbolic Lisp machine. Okay, and anyway, not successful. Not successful because functional programming is still not really that easy for regular programming. Okay, mostly just two professors writing their own program, and other students don't understand what this programming is. So very awkward compared to C language. It is not really that easy to program in Lisp. So just belong to a few smart guys who can actually handle the complexity of recursion to do the programming. So at the end, it's a good idea, but the hardware cannot support it. And so basically, it actually, since 1958, this language had never been the mainstream for AI yet. So far, not. Okay. So far, recently, we talk about AI. Mostly, we are talking about neural network. We are not talking about this symbolic processing. Okay. A neural network, even neural network, neural network in 1996, I graduated from, get my PhD in this year, right? 1995, 1994, that year, we are using HP 5-micron technology, okay, and 0.25 micron technology. I still see 0.25 micron technology, okay. We build a chip, putting two neurons into there. Two neurons is just like a two processor core, but it's actually the what's that? Actually is a processing unit designed for neural network. But two neurons you cannot do too much, right? But it can actually do quadratic optimization. Okay, that's part of my dissertation. But this one is actually 2 micron, and then this is two core neural network take up 1 centimeter on the side. So already take up 1 square centimeter. Okay, that's back 1995. Now go to 2015 when AI gets started. NVIDIA. Okay, they have a GPU. So they already realized 180 digital core. The technology right now is 5 micron, 5 nanometer. So what's that? It's 1 to 1,000 smaller. So originally, if 1 by 1, you can put 2 neurons. Now it actually is, this one actually is, you can put, what? It's actually 1,000 times more, 1 dimension, 2,000 times more dimension. So in theory, the same code that we are using right now, you can put 2 million of the neuron into there. Okay, my neuron is analog, so actually it's smaller than digital one. But back 30 years ago, 2 neuron, now it grows to 2 million neuron. This is the main driving force for the AI right now, okay? The AI chip, because of the advancement in semiconductor, right now become possible. So hardware is very important in AI, okay? Hardware is very important in AI. So because of the shrinking of the semiconductor devices, we can put more process into there, and then some computation originally impossible now become possible. Parallel processing, multi-neuron network, you can put thousands of neurons onto NVIDIA GPU to process it. Back 1995, we know the neuron can work, but what? But the processor just cannot handle it. Okay, but the processor just cannot handle it. Same thing for this Lisp. In the 1960s, 70s, they built a Lisp machine, and they try to make it work, but eventually at that time, the semiconductor technology is not that good, so they don't get the best support for it. Okay, so still not working. And will someday this machine become important processing? We don't know. We don't know still. So in academic areas, people still trying. Okay, people still trying. So here still, when in academic area, they still try to teach this for research purpose. Okay, and textbook, you can find this from the slides. Okay, if you are interested. Tool, you can, I show you one tool, but if you have other, you want to try different tool, they are different tool. Okay, first thing is now let's look at this program. Lisp is based on the data type of a list. Okay, so basically here you have +3, 2. This is the beginning of the list. This is the end of the list representation in Lisp language. And then this is the element 1, 2, 3. Okay, it's just simple as that. So it's the same as your Python language. You actually put 1, 2, 3, something like that. Okay, I'm sorry. Your Python language, you put the plus sign and then 1, 2. If you mimic it in Python, it's actually like this. Okay, and your language here is here. There's no comma. Okay, and then usually when we do this processing, first one is verb. It's your operator. So this one actually is 3 plus 2. So you get 5. Okay? Is that okay? Second one, quotient of this one. So you actually get 15 divided by 5, 3. Okay, then this one is quotient. Quotient actually just means integer division. So sometimes we have integer division, sometimes we have the real division. This one is integer division. So integer division, you get this. Okay. So in case that you have 17 divided by 3, you will have 5, 15, 2. So you get 5. But if you use division, you will continue to get 5 point something, right? That's it. That's not integer BJ. So quotient is integer BJ. You get the quotient portion. Okay. The next one actually is, this is a little bit complicated, right? Look like a little bit complicated. But this one just means just the way that we write it. Okay. So here, basically, this is operand 1, operand 2. So you have 2 times 8. So you have 2 times 4, you get 8. 3 plus 5, you got 8. And then this one plus, so here you got 16. And minus 10, 7, so this one is 3. And then 3 plus 6 is got 9. So this one actually 3 times 16, you got 48. And then plus you got 57. So you have this one, operand 1, operand 2 way of writing. Okay. And if you need more detail, you actually do plus and then operand 1, operand 2. Is that okay? That's the way people write. I mean, in terms of alignment, suggested alignment in the suggested alignment for the what for this. So you align the operand together here. So verb, and then you put more operand. Sometimes it's not 1 or 2 operands. Sometimes you have multiple operands. Okay, for example, like this one is sum. And sum, you sum everything together. Is that okay? This is the alignment. Any question? Let's try. Okay, let's try. Talking is cheap. So let's do plus 3, 2. And plus 3, 2, you actually, at this moment, you say that Rocky language, okay? And then you want to run it. So basically, first you need to save that definition as, okay? So this is called definition file, okay? The program they have called definition file. And then let me choose a directory to store it. Okay, here let me create a new directory. Let me call it this EEV, okay. Let me create a dictionary, okay. Put it over here. And this one is called a.login. Okay, after saving it, that's wrong. You got 5, okay? And that's 2 more. Let's do plus minus 3, 2, okay? So 3 minus 2 and then plus 7 plus 2. Okay, 7 plus 2 is 9. 3 minus 2 is 1. So here, after that, you do save definition. So you save to the new file. And wrong. You got 5 and 10. Is that okay? That's how you do programming. Any question? And align your, because this is operator. I'm sorry. The operator and then operand. But we prefer you to write. If actually the operand is easy, you just write this way. If it is more complicated, you group them here. right? To do it. Okay, that's the alignment. Okay, let's actually look at the basic language now. That's the editor issue we finished. Let's actually look at the language now. So basically, whatever, okay, we don't have time to read this. So it's a weakly typed language with dynamic type checking, okay, whatever. Okay, so it's actually a function and two arguments. So the operator in front and then argument. Okay, so that's that. So here there's a syntax. Okay, the so-called syntax. E is impression, I is identified as available. There are some impression as available and constant. These are the basic ID terminology in scheme language. Okay. So plus 3 pi is actually 3 plus 5. Factorial of 6. Okay, factorial of 6. Let's look at factorial of 6. Let me put a slice smaller. And the next one, factorial of 5. Okay, factorial of 5 should be 120. Okay. So let's go on. There's no factorial. There is undefined. Okay. So this one I think is somewhere defined. Some function called factorial. Okay, we don't have factorial function yet. So this one doesn't work right now. Okay. Sorry. There is a separate function. We don't want to write it yet. Okay. So anyway, the first one is operator, second one, and third one. So here, this one is a list. Okay. But you can see that there is a single quote sign. Okay. So what does this single quote sign mean? This single quote sign means don't evaluate. Why it actually need to be don't evaluate? Because it's literal. So don't go into there to evaluate A as operator, B as. If you do not put a quote, you just write A, B, C. Then this program will recursively evaluate A, B with operators A to C. So that actually would be wrong. So this two just means that it's a constant list. It's a literals. Okay? It's a literals. So don't evaluate. Don't evaluate to. It's a prevention of evaluation on the list. So if you have a list you don't want to get evaluated, you code it, that become a constant literal. Okay. Okay, number is 1, 2, 3. Function call is factorial append and then big quote 1, 2, 3. Okay. So let me check. So factorial in okay. Okay, I'll search it for you. This one data type. Okay. Let's look at data type. So data type you have Boolean type. Boolean type constant is sharp T and sharp F. Okay, this is true and false. Okay. And then the variable atom or a string is A, B, C, D, whatever. These are the string. Okay. And you can use double quote as string to include a space there. Okay. Okay, empty list is this. Okay, this is empty list. Okay, it's a data type. So you have data type of this type, you have Boolean type, you have number type, you have string type. Okay. These are their data type. So you have A, B, C are string, 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 number, string, number, number, string, 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 okay, whatever, and entry list. So your basic data type are number, string, okay, and compound data type list. And you have one more basic data type, Boolean. So basic data type 3, data structure only one type, list, okay. And remember this one, if you use Python, Python can represent all of these, right? It can represent all of these. Okay, the number like this, and then you can actually also have the real and rational number, okay? You can write 2/3 as rational number. String, you can use a double quote, okay? Character, single character, you write sharp \C, okay, single character, sharp \A, single character. Okay, whatever these are the data type. And then they are operator plus minus divide. This divide is real division, okay? You get fraction. It's division. Integer division called quotient, okay? We talked about it already. So ABS square root, okay? Comparison. Equals and equals. Okay, this is equal in value and equal in data type. Okay, this actually later you would check equivalent and the equal. These are two operators. They are different. Okay, and they are logic and or whatever. Okay, and are short circuit logic. And or are short circuit logic. Short circuit logic means that if A and B, if A is false, B will not be evaluated. If there's an end, okay. If A or B, A is true, then all will not be evaluated. Okay, this is called short circuit operators. Okay, so these are basic operators, and let's see. There are numbers, integer pair. Okay, these are the question predicate to check it is a number. So basically, number question mark A is to check whether A is a number or not. Okay. So if you say pair D, you check if D is a pair. Pair is A, B, two value called a pair. Okay. Okay, these are the checking of the data type. Okay, checking of the data type. These are predicates. So applying function to the argument is like this, operator among the arguments. Okay, let's look at this one. So plus 2, 3. So this one you will get 5. Absolute value of -4, you get 4. Okay, time 2, 3, you get 6. Plus 6, 8, you get 14. Okay, plus 3, 4, 5, 1, you sum them together. This one is 7 plus 6, you get 13. Okay, so that's these are the results that I get for that. Okay, and remember that your first line you must write len logic. You can also write len scheme if you insist to use the scheme grammar. Okay, or you use a sharp len this. I think they are okay. Dr. Rocket will handle it. Okay, if you want to run the older dialect. But for me, I suggest just learn Rocket, okay? It's the newest one. Is that okay? The first line, you must write this learn Rocket. If you look at my editor, it's always like that, okay? The first line, don't forget to write this sharp then lock it. Okay, don't forget. Otherwise, it is a directive to talk about, to tell the interpreter that you are using that language. Okay, and they are dialect that Dr. Rocky can handle. Okay, more dialect. Okay, so this one is a basic computation. So next one is pair and list. So you can do construct 1, 2. Construct cons is called construction. Construction is to build a pair. So you return sharp quote 1, 2. Quote 1, 2 is actually one period to this one called pair. Pair is a tuple, just like a tuple in Python. So construct banana split, you create a pair. Okay, so pair is a compound data type, but it's not a list. It's not a list. It's actually called pair. It's a two entry tuple. Okay. Okay, and the value produced by cons is not always a list. Okay. Constructor actually is will build a list, but in general, the result of the constructor is a pair. The more traditional name for construction, okay, so we want to make a list. So basically, you can use a car to build a list. Okay. So basically, in a pair, in a pair and a list. So let's assume that we have a list 1, 2, 3. Okay. And we can build, if you construct 1, 2, it will give you a 1 period 2. That's called pair. Okay, that's called pair. That's a pair. And then you say car. You say car. Car will get the first element. So basically, you got the A0. You got A0 actually. So car, you get A0. Car, you actually get the list's leading element. This CDR, okay, cat, okay, cat. This is CDR, you get okay, the remaining elements. Is that okay? CDR will get remaining element. So let's try to practice this pair. Let's try to practice this pair, okay? So let's construct 1, 2. And run, you get a pair, okay? So let's do part of the construct 1, 2. So construct 1, 2, you get a pair of 1, 2, and part you get the first one, and then this CDR, okay, you get the rest of the list. Okay, you get 1 here, 2 here, okay? But remember, construction is to build a list, okay? And then actually, but this one, it doesn't build a list, it build a pair. If you want to build a list, you should use construct, okay, 1, and then quote 2 and 3. And let's look at this one. This one, you get a list of 1, 2, 3. So basically, this construct 1, 2, you build a quote 1 period 2. This one is a pair. Okay. If you construct one and a list. You become one, and then the list is here. It's merge one at the head of the list. So this one, construction, build a pair. This one, build a new list. Is that okay? So let's assume that actually you want to build a list. So here, let's do construct one to an empty list. So you actually build a list with only one element. Oh, it doesn't allow it. Let me use a quote. And you build a list of only one. Is that okay? That's the new list. If you just put the new list, and after that you can do construct one quote. Okay, here you actually can put a construct two. Okay. And this one will be a list of 1, 2. Okay. Any question? These are data structures. Okay. Data structures. Any questions so far? So we talk about data type and then pair and list. Okay. And then pair and list. And list is the most basic data type in this. So atom is single data. Pair and list, these are basic data structure in this language. Okay, just trying to do that. So now next one is define. Define is define variable. So you actually make this one can make a list as well. Okay, so this one assign it to list. So define is define a variable. So let me actually try this one now. Okay, so let me actually save. Okay, let me actually create a new one. And this older one that's actually close. Okay, let's actually try to define. So define x2. Define y3 plus xy. Now save definition as this one. Let me save it as B. Second program that we develop. Okay, so now variable comes in and run it, you get 5. Is that okay so far? So now we have variables. So now let's do define, okay, a list. Okay, list 1, 2, 3, 4, 5. Okay, and then car a list. And then Qatar a list. Is okay? Car get the first element. Qatar get the rest of the list. Any question? So why we want why car and Qatar are really important? Imagine why is important? Why car and Qatar really important? Because in recursion, we teach you the recursive processing. Every time sum of n will call sum of n minus 1, right? So you process the n, and then you need to get the rest of the data, right? That's one way. If you work on an array, we usually index 0, and then we actually make a call, say search integer array A, right? And then recursive call, we always search, okay? So we process A0, and then we will search A1 to the remaining part, right? So you actually try to recursive call the car part. Is that okay? A car part. So that's why these two functions are very important in this. It is used to get the data in the recursion, okay? We'll see that, okay? We'll see that. Okay, so here you do car, checking if A is the least, checking if it's a pair, and you can define a pair or a list, okay? Whatever, and you get the data here, okay? Anyway, these are basic operations, and they are these two functions. Yeah, these functions are important. How long is the list equals? These are checking condition, okay? Who reference list are they equals, okay? Car and the Qatar and the construct, okay? And whether the list is null or no, okay? So variable, okay, variable is using define, okay? We talk about it. But there is a bounding environment. You have to know about where you define the and become local variable, okay? So there is a scoping problem, but okay, so define x1, okay, and you can set x plus x3 plus x3. So here you have 1 plus 3, you get 4, and then set x to 4, okay? This is an update. This is define. This is the update. Set exclamation mark. Set q, okay. And construct x to here, you are adding 4 to the list. So you get this, okay? Any questions so far? So this one is define. Define is like integer s equals 1. This one is like x equals x plus 3.
I actually have a quick question.
Yes.
For define, I know you said it's like integer, but could you also use strings with it too? Is it we're kind of like Python towards any variable type, or is it specifically integers?
It can be integer, it can be a string, it can be a function.
Okay.
It even can be a function.
All right. All right. Thank you.
Okay. It can even be a function. So we haven't talked about function yet. Okay. We are coming to talk about function or define function. Okay. Coming soon. Coming soon. Okay. Okay. At this moment, we are dealing with the variable. So define clam 17. So clam will be 17. Okay. 14. Okay. These, I think these are easy. Okay. And this one is a lot. Lot and define are different. Okay. That is actually using for binding the local variables. So define this on this portion. Actually, x equals 3, y equals 4, but this x 3, y equals 4 only valid in the that domain. Outside of it, outside of that, the x and y doesn't hold the power. It's not bound. Is that okay? So when you do that, that only allows local variable to do the operation here. So it's a local variable, a functional label, local variable. Is that okay? So you can that and then actually put another parameter binding here, and then apply to all the expression below. Okay? That's that, local variable. Okay? So define R2X. This one is defined. This is like this. It actually is R2 of X. We will reverse X and the reverse X, append them together to a list. So let's try this one. Okay, let's try this one. This R2 function, double reverse function. Okay, so this one B is okay. Let me save it. Let me create a new one called C. Okay. So let's actually do here. We have a list. I'm sorry, define a list. Record 1, 2, 3. Okay, so we reverse a list. This one is 3, 2, 1. Okay, so that's a single reverse. So that's define R2X. I don't want to write it in one line. Okay. Is that okay? That's the way I'm doing programming in Scheme. Let me see if I can increase the font size. So you can see better. Okay, let me increase the font size. Any question? So this is usually the way we write it. So operand, you reverse X operand, you append these two operand together. And you define a function called R2 of X. So R2 operates on A list. A list is 1, 2, 3. So you get reverse, append together. Got it? This is one function. Any question? Okay, there's some homework on this, okay? So there's a lat star. Lat star is different from lat, okay? One problem with that is that while binding are created, expression cannot refer to the binding that already made previously. So for example, this doesn't work. So you have x3 and then plus y plus 1, this one, okay, and this doesn't work if you want to have the 3 being used to here, okay, is parallel processing for that. So basically the 3 won't carry to here. In order to do that, you need to use the lat star. And this definition will be used here. Okay? Is that okay? This is the difference between lat star and that. And anyway, these two are local variables. And it just allows this one to be operated and then return return S plus 3. Okay. I'm sorry, return 3 plus 4. Okay. Okay, that's a lot. And function, we actually have lambda function as well. Okay. You can also use anonymous lambda function. So lambda function is lambda and then parameters and then expression. So you actually do get a parameter and then work on the value will be the expression. Okay. So lambda sy is actually this is a function f of s1 or s2, and you have s1 minus s2 and s1 minus 2 and time together. So this one pretty much is s1 minus s2 square. This is one function. You return a function of this. Okay, so this one you actually function and then two values. So let's look at this one, lambda expression. Lambda expression is a function of no name. So you do lambda okay, sy, okay. So you return the value of s and y, okay, this is lambda value. And then you apply to 5 and 2. So you apply s plus y to 5 and 2, you get 7. So this one, the whole lambda thing is an operator. Apply this one to 5 and 2. Okay? It's a lambda expression. You define a function on the fly. Any question? Okay. Then you define function, okay? Function, we talked about it already. So here we don't waste time to go into there. Equality, now let's look at if statement, okay? Conditional statement, conditional search. Okay, let's look at a conditional statement now. So equality, you have equal v, equal EQ, okay? EQ is a pointer comparison. EQV is actually with evaluation, okay? So it returns T if the argument refers to the same data structure, okay? This is called equal EQ, okay? EQV need to same value, okay? EQV is same value. And then equals return true if the argument has the same structure. Same structure, okay, whatever, you will know it when you use it, okay? So there's a 3 types of equality, equal, EQV, and EQ, okay? Question. So let's look at this one. We do have defined claim as 1, 2, 3. So this one actually claim pointing to a list of 1, 2, 3. And then define apters. So apters are also pointing to the same data. So EQ these two, yes, they are the same. EQ claim, yes, they are the same. EQ these two, they are the same. They are pointing to the same object. But EQ clamp with another list 1, 2, 3, 4. There's a different 1, 2, 3. When you write this one, it's a different one. So different object you are pointing to. Not the same. So these two are not the same. Okay. And EQ this and this, not the same. Still false. It's different 1, 2, 3. Still not the same. EQ 10, 10, they are same value. EQ 10.0, 10.0, they are same value. EQ 10, 10, they are same value. EQ 10, 10, 10.0, 10.0, they are same value. EQ 10.0 and the 10 is not the same, one integer, one real value. Okay, so equal value is equal value, equals equal reference, equal pointer. Okay, EQ clamp with 1, 2, 3 is the same. It's the same this structure. Okay, so this one compare pointer, this one compare value, this one compare contents. 3 are different purpose. Okay. Okay, anyway, these are boring, so just as kind of, so we need to look at the operator. So you do have the and, or, and conditional. Okay, you have if statement. If condition, you return true, else you return false. Okay, this is if statement. So if equals 5, this, okay, if 5 equals 2 plus 3, then you return 10, otherwise you return 20, and apparently you return 10. If 0 equals 1, you return 1 divided by 0. It won't happen. So you return 2 plus 3, you return 5. Okay, so this is the structure of if form. Okay, so this one you define my maximum as y. If x greater than y, you return s, otherwise you return y. Okay, this is the define a maximum. Okay, my maximum among 10 and 20, you return 20. Okay, and you define my maximum three numbers, and you compare x greater than y and x greater than z, then you return x. If not, if you compare y and z, return the bigger one. Okay, it's an if statement. And you can have a conditional statement if the first condition pass, you return this. If the second condition pass, you return this. And default case, this is a little bit like switch in Java. Okay. Okay, so can define this one if f greater than 80, return 2 half. Okay, something like that. Okay, the switch statement. Okay, so here we do have this different one. Okay, next one is the scheme cheat sheet. Okay, so here there's a function called evaluation. You can use evaluation to evaluate some program. Okay. So there's a defined called lambda, condition, and that. Okay. Let's see, these are not important part. They are built-in functions you can use. Let me see, is there anything important now? These are more theoretical. Okay, they are higher order function called map in functional programming. Map, filter, and reduce. Okay, map, filter, and reduce. Dr. Rocket support the first two. Okay. Okay, and the rest of them is too difficult. Let me go back to the example, okay? So let's actually do our then programming training now. We do go through the language roughly, okay? So let's actually create a new one. Okay, new one, let's actually try to work on, okay, the first function still work on the maximum function, okay? So this one you get a maximum amount X and Y, okay? So that's the same now. Now we want to actually do define, okay, some actually sum n, okay. Sum n actually is a function, okay. So sum n will actually call sum okay. So the first one is the maximum among 2 and 3, right? This one is recursive definition of sum n. If n equals 0, return 0, okay? And then otherwise return sum of n minus 1 plus n. Is that okay? Any question? Okay, I'm writing practical programs, okay? Okay, let's continue. So right here, let's do if I got an array, how to calculate the sum of the array, okay? Sum of the array, so here, If the length of the array equals 0, you return 0, right? Otherwise, you would recursively doing sum plus. Don't call it sum, okay? That's sum x. Don't repeat the same name, okay? It's okay? You get 6. Okay, this one we write into the Java format. It will be sum x of the integer array ARY, okay? If ARY the length equals 0, return 0. I'm sorry. Actually, in Java, you have to use the index, okay? I shouldn't write it this way. But anyway, here you just check if the length of the ARY equals 0, you return 0. Otherwise, you return the first element and the sum of the rest of the array, okay? Is that okay? So you see the recursion will teach you, will be useful when we come to writing this scheme program, okay? That's the whole purpose that we go through the recursion. And now you can exercise on a new language. See how fast you can pick up this language, okay? And my purpose of doing this is to show you the simple example for you to learn recursion and master this scheme language, okay? So any questions so far for today? If not, I'm going to finish our talk today up to here, okay? Because you can go in further, but that would be more programming. You need to exercise some scheme language, okay? Any question? I'm going to send this ABCD kit to you, okay, by email. Okay. Okay, no question. That's it for today. Okay, thank you. See you next time. Okay, bye-bye.